Good day, everyone. Our topic for today is all about introduction to limits. And welcome to Basic Calculus. Ito na yung ating unang step. So let's start. First thing, what is a calculus? So yung calculus is also known as infinitesimal calculus. Yun yung kanyang original name, or the calculus of infinitesimals. So it is a mathematical study of continuous change. So pag-aaral natin ito yung rate of change and so on and so forth. Infinitesimal calculus was developed independently in the late 17th century by Sir Isaac Newton and Gottfried Wilhelm Leibniz. And today, yung calculus ay sobrang lawak na ng application, especially in science, engineering, and especially in economics. So, wag natin patagalin. So, let's start with limits. So, what is a limit? Limits is a basis to calculus. So, ito yung backbone ng calculus. So, ito yung start ng calculus. So, hindi tayo pwedeng umusad ng calculus na hindi natin alam yung concept ng limits. We have two goals for calculus. So, ano yung dalawang goal na yun? The first one is if we have a curve or any curve, the first goal of calculus is to find the slope of a tangent or tangent line to a point on a curve. Again, finding the slope of a tangent line to a point on a curve. If we're given a point like this, so yung goal natin is hanapin yung slope nung curve at that point, and after that, makakagawa na tayo ng tangent line. Now, yung questions, okay, madali lang naman gumawa ng equation ng line. Kasi alam natin, we have y minus y1 equals to m times x minus x sub 1. Madali lang gumawa ng equation ng line. But, ito yung tanong. Meron kang point? Yes. Meron ka bang slope? And the answer is, wala. That's an issue. So, kaya yung slope is a big deal for calculus. So, paano ka kukuha ng slope kung isa lang yung point mo? And we know, dun sa ating past lesson, we need 2 points to make a line. So dito, ang given lang sa'yo, isang point. Kailangan natin 2 points to make a line. So again, that's a problem. So yun sasagutin natin maya-maya lang. Okay, and the second goal is to find the area under a curve between 2 points. So ano yung tsura nun? So let's say we have a curve like this, and any curve naman, pwede. And we have points A and points B sa ating x-axis, or pwede nasa y, but in this case, sa x-axis tayo. So, yung goal natin is to find the area under this curve, like this. So, kailangan hanapin natin yung area niyan. Ang tanong, paano hanapin yung area niyan? Una, hindi yan circle. Hindi rin yan rectangle. Lalong hindi naman siya triangle. O paano natin kukunin yung area niyan? Okay, and that's a problem. So, yun yung gagawin natin. By the way, yung pagkuha ng slope of a tangent line to a point on a curve, ang tawag dito is differential calculus. At yung pagkuha ng area under a curve, ang tawag natin doon is yung ating integral calculus. So at this moment, dun muna tayo sa concept ng limits bago tayo pumunta sa dalawang ito. Okay. So let's start with a tangent problem. So suppose, meron tayong curve line at meron tayong specific point. And let's call this as point P. Now, ano yung goal natin? Yung goal natin is to make a tangent line dun sa curve. Now, you need 2 points to make a line. Isang point lang yung meron tayo. So, hindi tayo makakagawa ng tangent line. Hindi pa tayo makakagawa ng tangent line. So, ano yung gagawin natin? Magkikreate tayo ng another point at tatawagin natin siyang point Q and gagawa tayo ng isang line. Yun nga lang, itong line na to, ang tawag natin dyan is secant line. So, yung secant line natin is a line that pass through a curve in 2 points. So, parang sa circle, nung tayo ay grade 10, yung secant line, ito yung line na dumaan dun sa loob ng circle. Pag sinabing tangent, ito yung nasa labas lang at dumaan lang siya at exactly 1 point dun sa ating circle. Tangent is a line that passing through a curve at exactly 1 point. Now, we know PQ or line PQ is a second line. Kasi dalawang points yung tinamaan niya. Now, yung goal natin is makakreate ng approximation para dun sa ating tangent line. Nadadaan lang dun sa point P. Suppose na yung point P is fixed or hindi siya nagagalaw dyan, pero yung Q is movable. So, yung point Q, pwede natin siyang igalaw, pwede natin siyang iusad kung saan natin gustong ilagay. Okay? Now, saan natin ilalagay yung point Q para maging approximate siya or super close siya dun sa ating tangent? So, we know ito ay secant line at yung goal natin ay maging tangent line to. Ano ngayon ang gagawin natin sa point Q? Ilalapit ba natin sa point P or ilalayo natin? And the answer is, syempre, para maging mas kamukha siya nung ating tangent, kailangan ilapit natin yung point Q dun sa point P. So, ilalapit natin siya like this. So, ito yung magiging secant natin. And hindi pa siya good approximation ng ating tangent. So, lapit pa natin. Hindi pa rin siya good approximation kasi dalawang point pa rin yung tinamaan. So, lapit pa natin. So, hindi pa rin siya ganun ka super close sa ating tangent kasi dalawa pa rin yung point na tinatamaan niya dun sa ating curve. Now, when do we stop? So, kailan tayo hihinto? Now, here's the idea. As Q gets close to P, itong point Q is get close to point P, the secant gets more closely approximates the tangent. Okay? So, habang nilalapit natin yung point Q dun sa point P, yung secant line ay magiging almost the same nung ating tangent line. Nakukuha? Now, note that we cannot let Q is equals to P. So, hindi natin pwedeng yung point Q, ilipat natin ng sobra at gawin natin equals to P. Bakit? Kasi you need 2 points to make a line. So, babalik tayo dun sa unang statement natin. You need 2 points to make a line. O, paano tayo gagawa ng line kung equal lang sila? Di isang point na lang yun. Nakukuha? So, ibig sabihin, ilalapit lang natin yung point Q super close to point P. So, kapag ginawa natin yun, yung point Q, inilapit natin ng super close sa point P, yung secant line ay magiging super close dun sa ating tangent line. You get the idea? So, ulitin ko. Kapag yung point Q, inusad natin na super close dun sa point P, yung secant line ay magiging super close dun sa ating tangent line. So, if we let Q get super close to point P, the secant will be identical to our tangent line. And that idea is what we call the limit. Wherein, kaya natin pagdikitin yung dalawang point na super close na kahit na konting difference, wala tayong makikita. Now, yun ang pinaka-cool idea ng limit. So, pwede nating palapitin na super close, almost zero, pero hindi sila equal. Pero yung difference nila, it doesn't matter. And that's a limit. Okay, para mas maintindihan, gawa tayo ng example. So, apply natin yung tangent problem. So, we have a parabola y is equals to x squared. So, the question is to find the equation of the tangent line to y is equals to x squared at 1, 1. Now, madaling gumawa ng equation ng line kasi meron tayong formula, y minus y sub 1 equals to m times x minus x sub 1. Okay, meron ba tayong point? Yes, meron tayo. 1, 1. Yun yung pinakamadaling part. Meron kang point. Meron ka bang slope? And that's the hard part. So, yun yung kailangan natin gawin. We have a point. Given na yan eh. 1, 1. Yung x sub 1 natin is 1. Y sub 1 natin is also 1. Pero meron ba tayong slope? And the answer is wala. And that's the hard part. Yung point, that's the easy part. Yung slope, that's the hard part. At yun yung kailangan nating gamitan ng limits. Okay, so equation for the tangent. So yung goal natin, itong m is yung slope ng ating tangent line. So, y minus y sub 1 equals to yung slope ng tangent line, kasi yun yung kailangan natin, equation ng tangent, times x minus x sub 1. Now, paano natin makukuha yung slope ng ating tangent line? So, una, gamitin natin yung concept na napag-aralan natin kanina sa tangent problem. So, lagay natin yung point na given, which is 1, 1. And this is fixed. Next, we create another point na x, y, which is movable. Ibig sabihin, pwede natin itong igalaw anywhere we want sa ating y is equals to x squared na graph. Pwede natin siyang igalaw. Next, kung mapapansin, meron tayo ditong x, y, and yung y is also equals to x squared. So, mas maganda gumawa tayo sa single variable lang. So, yung y, papalitan natin ng x squared. Bakit natin pinalitan? Kasi yung y is also equals to x squared. Okay? So, wala namang problema sa part na yan. So, ibig sabihin, lahat ng points dito sa ating parabola is nagko-contain ng x, x squared. For example, yung point na 1, 1, nasa parabola yan, na x squared. Next, yung 2, 4, yung 3, 9, yung 4, 16. So, lahat ng points na yun ay nandoon sa ating parabola. Nakuha, pwede nyo i-graph or nagawa naman natin to nung nasa pre-calculus tayo. Next, yung goal natin ay i-approximate yung tangent. Okay? I-approximate yung tangent. So, gumawa tayo ng point. So, gagawa tayo ng secant line. So, tayo secant. Bakit siya secant line? Kasi dumaan siya sa 2 points dun sa ating graph. Yung tangent kasi only 1 point lang. Nakuha? Next, kailangan natin kunin yung slope ng ating secant line. So, paano ba ulit kinukuha yung slope ng line? Kung matatandaan, meron tayong formula in finding the slope. We have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Kaya natin siya ni-review ng ating mga past lesson. So, we have slope ng secant. So, specify natin, slope ng secant yung pinag-usapan natin dito, is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Next, i-substitute natin yung mga values natin dun sa ating formula. So, slope ng secant equals to x squared minus 1. Bakit naging x squared minus 1? Ito yung ating y sub 2. Ito yung ating y sub 1. X squared minus 1. All over, x sub 2 natin is x minus 1. So, we have x minus 1. Okay, now, yung goal natin is palalapitin natin yung point Q. So, ito yung point Q. Palalapitin natin into point P dun sa 1, 1 hanggang sa maging super close na siya. So, para magawa yon, gagamit tayo ng table of values. So, we have x, variable x natin, and yung ating kalalabasan para dun sa slope ng ating secant line. Now, as Q gets closer to point P, yung ating secant line ay magiging super close dun sa ating tangent line. It follows na yung ating slope ng secant line is magiging super close dun sa slope ng ating tangent line. Okay? But, pwede ba natin gawin yung point Q is equals to point P? So, pwede ba natin yung x is equals to 1? Okay? Kasi lumalapit tayo dito sa x coordinate. Pwede bang maging x equals to 1? Kamukha nung ating point. And the answer is no. So, pwede natin itry. Plug in 1 to this equation. 1 squared is minus 1 is 0. 1 minus 1 is also 0. 0 over 0 is indeterminate. So, there's a problem. Walang value yun. Kaya nga, bawal na gawin natin yung Q is equals to P. Bakit? Kasi wala tayong makukuhang sagot. Ba't wala tayong makukuhang sagot? Kasi isang point lang yon. Ilan ba yung point na kailangan natin to make a line? Kailangan natin ng dalawa. Okay? Pag ginawa natin silang equal, edi wala tayong makukuha. Kasi nga, isang point lang yon. Nakuha po ba yung idea natin? Now, ang gagawin lang natin, palalapitin natin ng super lapit itong orange na point papunta dun sa pulang point. Na sa sobrang lapit nila, halos wala na silang difference. Yun yung goal natin. So, yung 1, wala tayong pakialam dyan kasi wala na tayong mukhang sagot dyan. Now, habang lumalapit tayo sa point 1, papunta sa kanan, ito yung mga points na dadaanan natin. 1.1, 1.01, 1.001. Now, kung gusto mo pang dagdagan, pwede kang gumamit ng 1.00001 kung kaya pa ng mga calculators ninyo. Okay? Ito ay galing ng kanan. Now, galing ng kaliwa. We have 0.9. Ito ay 0.99. Ito ay 0.999. So, again, pwede mo ulit dagdagan 0.99999 kung kaya pa ng inyong mga calculator. Okay, now, let's plug in 1.1 to our equation para sa slope ng secant and let's see kung ano yung mangyayari. So, gamit tayo ng online calculator. So, yung 1.1, ipapalit natin dun sa x squared of minus 1 all over x minus 1. So, gamit tayo ng online calculator. Online scientific calculator. Okay, pwede na to. So, since gagamitin natin ay, balikan natin. Ano nga ulit yun? X squared minus 1 over x minus 1. So, yung x, papalitan natin ng 1.1. So, lagyan natin ng parenthesis. Kasi nasa numerator siya. So, parenthesis ulit kasi papalitan natin 1.1. Ito yung x, then squared natin. And then minus 1. Close parenthesis. Kung nag-open tayo, magko-close tayo. Divided by. We have parenthesis muna para dun sa 1.1 para madaling palitan mamaya. Close parenthesis, minus 1, and then close parenthesis ulit. And then hit equal sign. So, we get the answer 2.1. Balik tayo. Okay, so the answer is 2.1. Next, we do the same thing. Ipalit natin yung x na 1.01 dun sa ating equation na x squared minus 1 all over x minus 1. And gamit yung calculator nyo, makukuha yung sagot is 2.01. Next, if we plug in 1.001, ang makukuha yung sagot is 2.0001. Ito ay galing ng kanan. Now, paano naman yung galing sa kaliwa? So, if we plug in x is equal to 0.9, ang magiging sagot natin, gamit calculator is 1.9. If we plug in x equals to 0.99, makukuha natin sagot is 1.99. If we plug in x equals to 0.999, ang makukuha natin sagot dito sa slope ng ating secant is equals to 1.99999. Mula sa kanan at mula sa kaliwa, kung mapapansin natin, ito ay 2.000001. Magiging ganyan yan pag pag nilapitan pa natin dun sa 1. Ito naman galing sa kaliwa, kung mapapansin, ito ay 1.9999999 or simply both direction mula sa kanan at mula sa kaliwa, ang tinutumbok na value ay 2. So, ito ay 2 at ito rin ay 2. So, sa makatuwid, ang tinutumbok nila kapag papalapit na, pag ipinalalapit natin yung point Q dun sa point P, yung slope ng secant line ay lumalapit sa point na 2. So, as Q gets closer to P, yung point Q gets closer to P, yung slope ng secant ay lumalapit sa point na 2. So, what does it mean? What does it mean? If yung slope ng secant gets closer to 2 or approximate 2, habang lumalapit tayo yung point na yun dun sa point 11, it follows na yung slope ng tangent line is actually 2. Okay? So, ulitin natin. Naging equal ba sa 1? And the answer is no. So, lumalapit lang tayo. Habang lumalapit tayo, napapansin natin na yung ating slope ng ating secant ay super close dun sa 2 or approximates 2. It approximates the value of 2. Now, it follows na yung slope ng ating tangent line is actually 2. Pakita natin mamaya dun sa Desmos kung paano siya mangyayari. So, we have y minus y sub 1 is equals to the slope ng tangent, meron na tayo niyan, times x minus x sub 1. So, y minus y sub 1 is equals to 2. Ito yung ating nakuhang slope ng tangent. Paano din siya nakuha? Pinalapit natin ng super close yung point na to papunta dun sa 1, 1. Pero hindi siya nag-equal sa 1 kasi alam natin na walang sagot dun. Okay? So, super close lang siya galing sa kanan at galing sa kaliwa. At ang nakuha natin sagot ay 2. Next, yung 1, once natin nakuha to, yung ating x sub 1 saka yung y sub 1 natin. Next, simplify natin. Y minus 1 equals to 2x minus 2. Plus 1 both sides, we have y is equals to 2x minus 1. And that's the equation of our tangent line. Now, double check natin yung ating sagot gamit yung ating Desmos. So, tingnan natin kung yung y minus 2x minus 1 ba ay tangent dun sa y is equals to x squared at dumaan lang siya sa point na 1, 1. At isang point lang dapat yung tinaanan niya. Kasi siya ay tangent line. Okay, so una lagay muna natin y is equals to x squared. So, ito yung ating parabola. Next, gawin natin yung line natin. Yung line natin ay y is equals to 2x minus 1. Here we go. Now, as you can see, saan siya dumaan? Nakikita niyo ba kung saan siya dumaan? Anong point yon? Yung point na yon is a point 1, 1. At wala siyang ibang dinaanan, kundi yung point 1, 1. Therefore, yung y is equals to 2x minus 1 is tangent dun sa ating y is equals to x squared at point 1, 1. Hindi siya secant, iyan ay tangent. Diyan lang siya dumaan. Okay, ano ibig sabihin nun? Our answer is correct. So, we're done.